Alright, 6th graders, this is Math Lesson 91 about probability. Hopefully this lesson will be short and sweet, but basically what we need to understand when it comes to probability is that the word probability means chance, or the possibility of something happening. Sometimes people might talk about chances of winning, different odds sometimes people will use, but basically that's all we're dealing with when we think of probability. There are two ways you can think of probability as far as using it to answer questions on your homework. The book calls it this. It says favorable outcomes versus possible outcomes, so think of it like a fraction. I like to call it real results versus the possible results. In other words, what could actually happen versus what actually will happen versus what might happen. Alright, so thinking along the lines of fractions here, either one of these, whichever one is easier for you to understand, is what I would advise you to use. But if we look at the question here, it says, what is the probability that a coin will land heads up? Well, if we think about a coin, we know that there are two sides, and every time you flip a coin it only lands on one side. So if we use one of these two examples, I'm going to use my example, real results versus possible results, we write a fraction. And we said with a coin there are two sides to the coin, so that is, if I wrote real over possible, or if you like the other one is fine too, favorable versus possible. There are two possible outcomes. Either it'll land on heads or it'll land on tails. But of course when you flip the coin, it's only going to land on which side? How many sides? Well, of course we know it can only land on one side. Not possible for a coin to land on both sides at the same time. So when it says what is the probability that a coin will land heads up? Well, every time you flip a coin you have a 1 in 2 chance, or a 1 in 2 possibility that the coin will land heads up. And then of course one other thing we want to do is see if that can be reduced. Of course we know those are in lowest terms. We've already got a 1 there in the numerator, so no need to try to reduce that any farther. I guess if we wanted to be complete we would say 1 out of 2 chances for heads. Okay? Now the next two questions, or well, excuse me, the next question might be a little bit more difficult for you if you're not familiar with what it's asking. But the question nonetheless says, what is the probability of drawing an ace from a deck of 52 cards? Now, if you're familiar with cards, which, you know, if you're not, it's not a big deal either. If we were in actual class, I would be showing you pictures of a deck of 52 cards. But in a deck of 52 cards, there are 4 different suits. And what we mean by that, as far as suits are concerned, is there are a set of aces, or excuse me, there are a set of clubs, there are a set of diamonds, spades, and I can't remember, but there are 4 different suits. And each suit has the same amount of cards. It goes from ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, king, queen, and jack. So every single suit, all 4 suits, have the same amount of cards, same numbers, same faces, just like I said, different colors, the hearts, the spades, clubs, so on and so forth. Okay, so every deck only has 4 aces, every deck has 4 twos, well, every deck, each of them have one of those. So if you line them up, you would see an ace in each color, a 2 in each color, 3s, so on and so forth. And so when we think about the probability of drawing an ace, if you were to pick a card out of a deck, what are the chances that you're going to draw an ace? Well, again, we go back to either favorable outcomes, like we were looking at earlier up here, favorable outcomes out of possible outcomes, or real results versus possible results. So when we think about that, that information that you may have just learned about if you weren't already familiar with, we would say, of course, the possible, because remember we always write it in fraction form. It's real over possible. Well, we know that the possibility, there are 52 cards that you could draw. But the chances out of those 52 cards of drawing an ace, well, remember how we said there's only so many aces in a deck? One for each suit. There are 4 suits. So that leaves us with 4 possibilities, because there's only 4 aces in the deck of 52 cards. So the only thing we would have to do left, once we figure out the real answers versus possible answers or results, is check to see if we can reduce. And when we look at 4 and we look at 52, if you remember your divisibility rules, these are even numbers, so we know that they will both be divisible by 2. So 4 divided by 2 is going to give us 2. 52 divided by 2, let's see, 2 can go into 5 2 times. We've got a remainder of 1, so that's 12. 2 goes into 12 6 times. Now again, if you notice, we should have used a higher number because these are still even numbers, which means we can reduce it farther. Again, they're even, so that means 2. 2 divided by 2 gives us 1. 2 goes into 2 1 time. 2 goes into 6 3 times. So what is the probability of drawing an ace in a deck of 52 cards? You have a 1 in 13 chance for aces. Circle or box the final answer. Okay, last problem. Sometimes probability could also be used in form of percent. So this last question says, the weather report stated a 40% chance of rain. What is the chance that it will not rain? Now when you think of percent, we always want to think of percents in the form of completion or a perfect score, which would be 100. So anytime we talk about probability with percent, we always start with 100%. And so we start with that, and then we look at what this information gives us. It said 40% chance. So we're comparing 100 versus 40%. And it says what's the chance that it will not rain? So 40% is rain. We want to know what's not, what the chances are of not raining. So we're going to find the difference between those two. Now these are pretty easy numbers. 100 minus 40, of course we know is 60%. So we're going to say 60% chance of no rain. Then of course we circle or box our final answer. So that's all there is to probability.